Okay, so let's start now. So we're going to do work, energy, and power. But the first thing what you have to understand here is that for you to understand the concept of physics, you have to understand Newton's laws of motion and also equations of the motion. So if you are going to understand, or let me say, if you know Newton's laws of motion, meaning that where we are going right now is going to be very much easy for you. Okay? So Newton's laws of motion is very, very, very important. Because even here, when we're talking about work, energy, and power, we're going to be using some concept of Newton's laws of motion and equations of the motion. Okay? So the foundation of the physics is vectors, equations of the motion, and the Newton's laws of motion. If you know these three topics, you're not going to have any challenge in physics. So if you are still having some challenges in Newton's laws of motion and the linear motion, then it's going to be very much difficult for you to get the concept. Okay, so without wasting our time, let's start our discussion with work. Who can define work for us? What is work? What is work? How can you define work? Yes. Yes, please. Okay. So work is defined as the product of force and the displacement. So if you have got an object, here is my object. Let's say this is the ground. I have my object here. This object is going to have the mass. Okay. Let's assume to say we are applying the force in this direction. So this object is going to move from this point all the way to this point. Now it's going to cover a certain distance. That distance is what we are going to call the displacement. Okay. So if there is a force, we are applying a force, this object is going to move at a certain distance, then there is a work done. Okay. So work is a force times the displacement. Now, what you have to understand here is that whenever we're talking about the work, if the force, they are going in the same direction with the distance, the work done is positive. So you have the positive work done. And if the force and the displacement, let's say the force is moving in this direction, the displacement is moving in this direction, just know that the work done is going to be equal to negative. That is a very, very important, guys. Now, if the force and the displacement are moving perpendicular to each other, let's say this is the distance, it's going in this direction, you have the force moving there, making a 90 degrees. Then we can say that the work done is 0. So we have three scenarios here. If the force and the displacement are moving in the same direction, the work done is positive. If the force and the displacement are moving in opposite direction, the work done is negative. If the force and the displacement, they are moving perpendicular to each other, the work done is 0. Now there is a principle which you have to understand there. Why when the force and the displacement, they are moving in the same direction, the work done is 0, and why when they are in perpendicular, the work done is when they are perpendicular, the work done is 0, and when they are going in the same direction, the work done is positive. You have to know that. Okay, so there we go. Let's talk more about work. We are saying that if we have got an object, okay, I'll start from here. Let's say you are putting it at an angle. Okay, you are putting it at an angle. So this is the force which we have. Now, to find the work done, we are saying work is force divided by times what? Times the displacement. And remember, force is in Newton, the displacement is in what? Meters. This means that in 1 Newton meter, there is 1 joule. So the SI unit for work is just basically joules. So 1 Newton meter is equal to 1 joule. Okay, that is also very, very important. Now, before we go there, what we have to understand, guys, is that if I have, this is my force, then this is going to be pushed at a certain distance. Okay, it's going to be pushed at a certain distance. Let's say this is the distance. Let's call this distance D. Okay, now for us to find to calculate work here, what we're going to do here is we have to say work is going to be equal to, we are getting the distance which is going to be in the same direction with what? With the force. So this is the distance. We need to get the component of this force which is going to be in the same line with what? The displacement. So that component is going to be this one. So we can say that we have got 2 components. We have got the x component which is going to be fx and the y component which is going to be fy. So in this case, to find work, we're going to say work is going to be equal to fx times the displacement. But according to vectors, we know that if we use SOHCAHTOA here, I can find fx to say fx is going to be equal to f cos theta, meaning that where there is fx, I'm going to replace with what? F cos theta. So my work here is going to be f cos theta times the displacement. So in short, this is the general formula for work in all the cases. So work is given by f cos theta times the displacement. The reason why we are saying that it's f cos theta times the displacement, we are getting the x component of the force. The displacement and the force, they're supposed to be moving in the same direction, or not really in the same direction, but they have to be parallel. Okay, that is very, very important, guys. You have to know that. Now I want you to know the reason why we are saying that if the displacement and the force, they're moving in the same direction, why work done is positive. If the displacement and the force, they're moving in opposite direction, why the work done is negative. And if the force and the displacement, they're moving perpendicular to each other, why the work done is 0. Now let's see. We have come up with this formula to say the general formula is work is equal to F. We are saying that is F cos theta times the distance. Now, this is the general formula. Let's start with if the force and the displacement, they are moving in the same direction, the work done is positive. Why? Let's see. Let's say we have an object. Here is our object. So we have this, this is my object. I'm going to apply a certain force. Okay, let's apply this force. Now this is going to move at a certain distance. Let's say this distance, we call it D. Okay, now it's going to reach here. Okay, the force is moving. A force is a vector, guys. So this force, if it is moving in a straight line in this direction, okay, what would be the angle if they tell to say you have got a vector which is pointing toward east or toward positive x-axis? What is the angle? Hello, what is the angle in that case? If a vector is pointing toward positive x-axis or toward east, what is the angle? 0 degrees. Yes, meaning that if the displacement and the force, they are moving in the same direction, meaning that what we have to understand there is that the angle is going to be 0. Okay, so the theta in that case is going to be 0 degrees because it's moving toward positive x-axis. So if I do, what is cos 0? Cos 0 is 1. Okay, cos 0 is 1. So that's why you are going to see that always when the force and the displacement, they are moving in the same direction, the work done is going to be what? It's going to be positive, because cos 0 is positive, is 1. It's positive 1 in short. Does that make sense? Yes, it does. Now, if these two guys are moving in opposite direction, let's assume to say you are pushing an object in this direction. Okay, You are pushing an object in this direction, then there is another force which is opposing motion. In this case, let's say friction force. Friction force is going to be opposing the motion. Okay, since friction force is opposing the motion, and this now this force is directed toward the west, we can see that the angle is going to be what? 180. So if you do cos 180, you are going to see that it's going to be negative 1. Negative 1 times what we are going to have there, and the work done is going to be negative. So the reason is just simple. When the force and the displacement are moving in the same direction, the work done is positive, just because cos 0 is positive. It's going to give you positive 1. If they are moving in opposite direction, meaning that another one is moving in toward the west, then you are going to discover that the angle is going to be 180. Cos 180 is negative 1. Now negative 1 times anything which you are going to have is going to be negative. Now, what if these two guys are moving perpendicular to each other? Let's have the force there and the displacement in this direction. Okay, we can see that the angle which we are going to have for this force is going to be 90. So if you do cos 90, you are going to get a 0. Anything times 0, you are going to see that the work done, even if you say is F cos theta times D, you are going to get cos 90 as a 0. 0 times everything, you are going to get a 0. That is a very simple principle which you have to understand there. Does that make sense? Okay. Yes. So now, let's say we have let's say that we are applying a force in this direction. Okay, let's put this force at an angle. Okay, let's say that the angle is degrees. Here is our force. Okay, there is friction which is opposing the motion. That friction we're going to say maybe it's moving, so it's going to be the kinetic friction. Let's say that the mass of this object is 30 kgs. Okay, and let's assume to say the force which is being applied there is 50 newtons. As simple as that. So this is going to move at a certain distance all the way to, let me just extend it to here. It's going to move all the way to this point. And let's say that the distance in between is just basically 250 centimeters. Now the question is, what is the work done? And let's say that the mu value, the mu k is 0.33. So the first question is, what is the work done by the force, by the applied force? The work done by the applied force. The second question is going to be the work done by the friction force. The third question they are going to ask you is the work net. Okay, now let's start with the first question. So we want to find the work done by the applied force. How do we find the work done by the applied force? Remember, we are saying that the work done by the applied force, this is going to be our Fx, and this is going to be our Fy. Okay, so if that is going to be our Fy and we have our Fx, we know that the work done by the applied force is going to be equal to the Fx times the distance. Fx is F cos theta, so we're going to have this. If you have got a question, you can ask. We're going to have this. Okay, now we can plug in the values. My work done by the applied force is going to be equal to, the force which I have is 50 cos 30 degrees times the distance is 250 centimeters. I have to change these centimeters into meters. So 250 divided by 100, what are we going to get? Those having calculators, 2.5, right? Those having calculators is 2.5. So we're going to say times 2.5. Okay, so if you get your calculator, What is 50 cos 30, which is going to be 25? 25 times 2.5. I'm getting 62.5 joules. So this is the work done by the applied force. Does that make sense? Does that make sense? So the work done by the applied force, we can put it here. We are saying that is 62.5 joules. Now our next thing, we have to find the work done by the friction force. Yes, yes, please. Do you have a calculator? I'm not having my calculator right now. So what is cos 30? If you do 50 cos 30, those having calculators, please help me. It's supposed to be 108.25, right? Okay. So it's supposed to be 108.25 joules. So I'm going to put it here and say my work done by the applied force is 108.25 joules. I'll leave it there. I'm done with part 1. Now part 2 is saying, what is the work done by the friction force? Remember, the friction force is opposing the motion. Before you even find the answer, the friction force is opposing the motion. And I mentioned to say, if the displacement and the force, they are moving in opposite direction, what would be the work done? Hello? What would be the work done? It will be negative. Now, this is what we're going to have. We're going to say the work done by the friction force is going to be the friction force itself times the displacement. The distance is going to be the same actually. Now, what is the friction force? This is what I was telling you now to say, if you didn't understand the Newton's laws of motion, it's going to be very much difficult for you to solve this. Friction force is mu times the normal force. Now, this normal force is not going to be mg in this case, because the applied force was applied at an angle. Okay? So what we're going to have here is this. This is what we're going to have. Let me just shift this just a bit. I put it here. What is happening here is, for you to conclude to say the normal force is equal to mg is in this situation where you only have the mg pointing down, which is the weight force actually, and the normal force pointing upward. So what you know is the summation of all the forces in y direction. Since the object is not moving in y direction, the summation of the forces is going to give us 0. What forces do we have? We have got the normal force pointing upward minus the weight force pointing downward is equal to 0. We shift the weight force to the other side, the normal force will be equal to the weight force. This is the only scenario where you say the normal force is equal to mg, where I see the weight force. But now, in a case where you have another force which is pointing upward, like in this case, as we can see, if I get this free body diagram here, let me just do this. If I get this, I can see that there is the normal force, quite okay, which is mg, pointing downward, or the weight force, sorry. There is the normal force, which is pointing upward, but there is also another force which is in y direction, which is Fy. So therefore, what I'm going to do now here is, I'm going to do this. I'm going to say the summation of all forces in y direction, when I add them, they are supposed to give me 0. What force? We have got the normal force pointing upward plus the Fy pointing upward minus the weight force, which is the mg pointing downward, is equal to 0. remember our goal is to find the Fn. So my Fn in this case is going to be, I'm going to shift these two guys to the other side. I'm going to have the mg, since it's negative, this side is going to have a positive minus fy. But fy, since it is in y direction, using SOHCAHTOA, you can see that it's going to be f sine theta. Okay? Then I'm going to say that my Fn is going to be equal to mg minus f sine theta, meaning that this is going to be my normal force now. So this is what I'm going to replace now here. If you want, you can find in advance and put it there, find the friction force. Or if you want, you can just keep on coming with what? The same formula you say. Let me get rid of this. We're saying that Fk is equal to, I'm going to say that the work done by the friction force is going to be equal to, remember it's going to be negative, okay, since it is opposing the motion, so it's going to be negative mu times the normal force times d. But what is the normal force in that case? So the normal force in that case, I'm going to start now to say the work done by the friction is going to be negative mu. What is the normal force? Normal force is mg minus f sine theta times d. If you want, you can find this one in advance and just plug in the value there. Now from here, I can plug in the values. I can say the work done by the friction force is going to be negative. The mu is 0.33. M is 30 times 9.8 minus, you have F, which is 50. I don't have space this side. I'll do this, which is 50 here. Sine the angle is 30 times the distance is 2.5. So that is going to be my work done by the friction force. Now, what's going to happen if I find the answer? I'm going to say inside there is 50 sine 30. 50 sine 30 is going to be 25. So you're going to say what is 30 inside there times 9.8. You are getting 224. 224 minus, okay, minus 20 what? Minus 25. I'm getting 269. 269 times 2.5. I'm getting 672.5. Then this one plus, oh, I have to do times now 0.33, which is giving me the work done by the friction to be 221 point. It's going to be negative 0.93 joules. As simple as that. Now, if the friction, in this case, I just made this question, but in actual sense, the work done by the friction, as long as that friction is kinetic friction, is supposed to be less than the work done by the applied force. Okay? Because that object, it was moving in the direction where the force was being applied. So now, what you have to do now from here, after finding the work done by the friction force, how do we find the work net? The work, you find it by adding the work done by the applied force and the work done by the friction force. So you say the work net is going to be equal to the addition of the work done by the applied force plus the work done by the friction force. So now this is going to be negative always, work done by the friction force. So you just plug in the values here to say the work done by the applied force, we have found that it was 108 point. I've forgotten on top there. But in actual sense, this was supposed to be the positive one. Okay, this was supposed to be greater than the work done by the friction force. I'm going to show you the question. I think I have one. So here, this one, we found that it was 108.22, I think to 23, plus this is negative. So in short, it is the work done by the applied force minus the work done by the friction force. Once you find this, that is the work net. Does that make sense? Does that make sense? Yes. Do you have questions? Do we have questions? Do you have questions on work? Yes, please. You can ask. What are you finding, Mama? You are finding 201.7. Okay, let's try it again. We are saying 30. Inside there we have 30. Okay, 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 okay. Okay, let's do this. Allow me, so that this question should make sense, allow me to reduce the coefficient of friction to be 0.03, so that because not in most cases, but always, the work done by the applied force has to be greater than the work done by the friction. So now if I put the mu value to be 0.03, what will be the answer now? Those having calculators, you can help me. 30 times 9.8 minus 25 times 2.5 times 0.03 I'm saying 30 times 9.8 minus 25 times 2.5 times 0.03. Okay, yeah, so now it's making sense. So now I'm getting this when I use the mu value to be 0.03. I'm getting my work done to be negative 20.18 joules. Confirm for those having calculators. So 20.18 joules is going to be my work done by the. Now to find the work net, this is where you need to be very much careful. The work net is the addition. The work net is the addition of the work done by the applied force plus the work done by the friction force. So you know that the work done by the applied force, it was 108.23 plus this is going to be negative, it's negative, so it's going to be negative 20.18 joules. So those having calculators, what would be the work net in this case? Our work net, so the work net is going to be, it's going to be what? This minus 108.23 need to be 110.83 joules. That is now my work net. Does that make sense? Does that make sense? You got 88 point. But this is true. Why can it be 10 but Nishi? This one is 108 and that is 20. It can't be 110. It's supposed to be 108. We are saying 108.23 minus 20.18. 88, right? Joules. That is going to be my work net. So under work, what you have to know is the only thing here which you have to understand, guys,
time the displacement, but the general formula is F cos theta times D. This is the general formula. Now we are saying that if the force and the displacement, they are going in the same direction, the work done is positive. The work done is positive. If the force and the displacement, they are moving in opposite direction, the work done is negative. If the force, they are moving perpendicular to the displacement, making a 90 degrees, the work done is positive. Is 0. The work done is 0. But what you have to understand here is this.
in general, work done is going to be only 0 if and only if the force and the displacement, they are perpendicular to each other. In 2021 past paper, I think it was question 3 part B. So here the question is saying a weightlifter lifts a 350 Newton set of weights from ground level to a position over his head, a vertical distance of 200 meters. How much work does the weightlifter do, assuming he moves the weight at a constant speed? Have you heard the question? Now, what is happening here is some people are thinking to say they didn't understand the question. This is the only key point here. Quite okay, this force was moving in this direction, but the key point of the distance here is the vertical. Okay, meaning that even the distance, if this is the force, which is 350 newtons, they are saying that vertical. So if you know vertical, there is vertical and horizontal. Unless if they say horizontal, meaning it was supposed to go there. So vertical meaning it is in the same direction there. Okay, meaning that is where now the 2 meters is. The 2 meters is. Do we expect our work to be negative or positive? Are you getting me? Do we expect our work to be positive or negative? So in this case, the work done, direct force times distance. The force is 350 times 2. So it is 350 times 2, which is 700. 700 joules and not newtons. As long as these two guys are moving in the same direction, the work done is positive. Work is equal to force times distance. So here you have just to understand to say it was vertical. It was moving in the same direction with what? With the force. As simple as that. So this is the question I wanted to show you. Unless if you're having questions, for today we can end here. We continue tomorrow. So for those who want to register, you can inbox me, because you are going to access everything on Moodle. I made the videos for Wake Energy and Power, and I solved some questions from past papers again, and you are going to access them on Moodle. So before it's too late, yeah, register with us so that we start now accessing the videos. Okay, so we can call it a night. Have a blessed night.